Hey, welcome back. Today we're going to do question number 3 out of the 75 I recommend you do in order to be ready for the next interview. So in this question, we're actually going to do something that's kind of fun, and I think it's kind of relatable. So let's dive into it. The question we're going to work on today is called Best Time to Buy and Sell a Stock. Cool. So let's read the first question, or the prompt. You're given an array of prices where prices I is the price of a given stock on the ith day. Okay, what this really means is that the indices will basically represent the day, right? Let's continue. You want to maximize your profit by choosing a single day to buy one stock and choose a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. All right, so let's try to understand this problem before we dive into it. So effectively, you're given an array of numbers, right? Where all the indices can be represented as, Monday, Tuesday, Wednesday, Thursday, Friday, etc., 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 right? But the actual values in that array are the value of a stock. So let's go meme a little bit. Let's call it GME, right? These are GME stocks. So your goal is basically to write a function such that you look at this array of stock values and tell me what is my maximum profit I could get, right? So some of the key things that they did mention is that you can only define profit as a buying at one price and selling at a future date, right? When you sell also has to be a higher price than when you buy, right? And of course, a simple profit math is you sell minus your cost, which is the time you bought, equals your profit. So we need to make sure we have to identify within this array what two numbers will give us the maximum profit, right? So let's go back into the question and look at some examples. Example number 1, you're given a 7, a 1, 5, 3, 6, and 4. So instinctively, if you look at this series of array, what two numbers can you see that can give you the maximum profit? Well, if you look at it, if I buy it at 1 and I sell it at 6, I get a maximum profit of $6 minus 1 is 5. Great, that is your solution here. Now, let's look at the second example. 7, 6, 4, 3, 1. This is an interesting one because if you look at this array, it's all in an ascending order. So what does that really mean? It means that the price is only going down. So in our mind, it can never make any profit, right? Because regardless of what item you buy in here, it's never less than the one on a later date. So in this particular output, we return a 0. Okay, cool. So let's look at some constraints that they list here. The price length. So basically the length of this particular array can be, it's going to be greater or equal than 1. That's great. That means it's always going to be at the very minimum 2 numbers because you need 2 numbers to get profit. That's great. And also, it's less than 10 to the power of 5. So it could be a long array. Cool. So let's try to dive deep and see how can we solve this problem. All right, let's look at, so what I always like to do before I go to any problem is look at the example and see if I can solve it in a brute force way. And maybe from the brute force way, I can start thinking about how I can iteratively improve this particular algorithm, right? So before we code, one thing I want you to look at is this. Okay, so the example I have here, which is the example they had, how can we identify that 1 and 6 such that our profit equals to 5? How does one actually do that, right? So we know for a fact that we have to go through all of these numbers in the array to determine whether or not you can find a pair, right? So at the very least, you need to go through every number, right? So we can just pseudocode a little bit. So I'm going to go through the array and decide, should I buy? Cool. So I'm going to go through this and say, hey, should I buy on $7? Right? And if I do buy, what do I need to check afterwards? Well, you're going to say, should I sell? Right? That's pretty much a high level. Okay, if I buy at $7, should I sell at 1? In this case, no, I should not sell. So what do I do in here? Well, I probably shouldn't, there's no profit to be made in here, right? So what can I do? I could probably move along to go look at 5. If I have my bought price at 7 and 5, did I make a profit? No. And continue. Do I make a profit at $3? No. 6? No. 4? No. Okay. So what does this really mean? It means that in this array, if I were to buy it at $7, I will never make a profit, right? So what do you do in this instinctively? Well, I'm going to move that buy price to here, which is going to be, if I buy at $1, will I make a profit in the future, right? I can always go $1. If I buy prices at $1, does my $5 equal to, is there a profit to be made here? Yeah, there is. It's $4, right? Then we could potentially record that $4, but that's not it. We're not done there, because if you look at 1 and we look at 3, wait, there's still profit here, but you know, the maximum profit here is $4 so far. So maybe this is only $2 if it's 3 minus 1. So let's move on to next. If that's 1 and 6, well, I have $5. $5 is definitely more than $4, right? So maybe that is my maximum profit. So let's keep track of some. Seems like we need to keep track of profit. So keep track of profit. We need to do something to do that. Keep track of my profit. Cool. So of course, 1 and 4, that's a profit that's less than this profit. So we can move along. And we could continue this process and checking and checking and checking, right? So effectively, in a brute force way, we can go through the array and decide, should I buy or not? And then I could go through the remaining array, go through remaining array, and decide if I should sell, right? And then, of course, over here somewhere, we're going to have to record the profit and see if my new profit is more than my memorized profit. So let's see if this would solve the problem. Oh, we also remember we have to return the profit. So return profit. Cool. So if we look at this the way we have it here, I think it does solve the problem. However, what we probably should be doing is to check our time complexity and space complexity. So let's check it out. So space complexity is equal to, over here is O of 1, because we're only keeping track of profit in this case. Let's look at our time complexity. Time complexity equals O of n times to the power of 2. Why is that the case? Because we're going through and checking on every value whether or not we should buy, and then we check the subsequent array over here again to see if we should sell, and we check every value and record what the maximum sell price would be. So a lot of the cases in here, I would usually ask the interviewer, hey, you know, do you want me to solve this problem and code the brute force way, or do you want me to potentially think about a more efficient solution? So in this case, I would suggest, you know, you can go and try to test it out and solve it the brute force way, but we're going to try to understand and assume, or trying to figure out a more efficient way to solve this, right? Because the most inefficient part of our algorithm right now is basically us always continuously checking the subarray for when to sell, when to sell, when to sell, when to sell, right? So let's see if we can improve this section right here, going through the remaining array and decide if I should sell. So let's revisit this question in here. What can we do, right? Instead of just going in here and checking this, like this initial value, and checking this whole array to see whether or not I should sell, maybe I can actually only just check one value next to me and infer some information from that. So let's check it out. What do I mean by that? If I buy at $7 and I sell at 1, does that give me a profit? Right? So effectively, I'm going to go and check my first pair. So I'm going to try to remove this, go through the array and decide and assume, go through the array and see if there is profit. Right? So I'm going to go through the array and see if there's profit. How do I see if there's profit? I'm going to be checking my basically I and I plus 1. So is there profit? If there is no profit, continue. Let's look at the next thing. If there is profit, let's think about it. So if there's no profit here, let's continue. If there is profit, which is this is the case, 1 and 5, what's our we keep track of our profit. So if there is profit, cool. Let's track our profit. Track our profit. So in this case, it's $4. Right? What do we do next? Let's look at the next pair. 5, 3. Is there profit? No. Then we continue. Let's check here. Is there profit? Yes, there is profit. And this profit is actually $3. Right? So, but remember our question here is asking what is the maximum profit, right? So if I know there is profit, I almost need to compare whether or not is my current profit more than my old profit, right? So in this case, well, it is more than my old profit. But however, is it actually more than my maximum profit? So we should look at one thing first. We should look at, well, if I were to buy at $3 and I sell at $6 and I get $3 as profit, we know for a fact that, hey, if we in the past bought at $1 instead, our new profit will actually be even more, right? So why don't we keep track of our original price? So let's keep track. Original price. So if there is a profit, well, let's check here, right? Check if my current purchase price is greater than my old one. I need to check, okay, since I know there's profit in here, can I check if my 3 gonna be greater than 1? In this case, yes it is. So we don't do anything, right? But if it isn't, say this was at 0, right? What should we do here? We should say that if my current price is greater than my old one, then I shouldn't do anything. How about if I go, if it's less than my old one, I'm just going to replace my starting price, right? I should replace my starting price. And if I do that, then next I'm going to check, okay, well, does this and this, is that more than my current tracked profit, right? So let's check, track my profit. What do I mean by that? All right, let's go check if is my computed profit, which is great now taking my new original price. Oh, well, computed profit, which is 1 and 6, right? Is that more than 4? Is our computer profit greater than old profit? If it is, track it. Cool. If we continue to go on with this particular algorithm, we stop here. We have to make sure we stop here before that array ends. So I think this does solve the problem. So let's actually try to code this now, right? The pseudocode's in here, it's up here, and the value here was originally 5. So let's actually code this problem. Original price. Let's set the original price. Let original price, or let's say buy price actually. Buy price will equal to, let's just set it at the first value for now. Prices at 0. In this case, it's $7. And let's keep track of profit. So let profit equal to $0 first. And remember, we have to return our profit. Cool. Now let's go through our array and see if it has profits. So in this case, for let I equal to 0, I is less than prices at I, prices dot length -1. Why I'm doing -1 is primarily because we do not want to, because right now we're iterating with pairs, right? That means that we don't want to iterate to the last value because we're never going to buy in the last value anyways. So we need to make sure that it's always I -1. Okay, I plus plus in here. All right, so let's include some of these things. See if there's no profit, you continue. So we don't need to write about that. If there's profit, so let's check if there's profit. So what do we do when we check if it's profit? Well, per profit is determined by these two values minus one another, right? So I'm just make a temporary variable in here. Let's call it like temp profit will equal to prices at I plus 1 minus prices at I, right? My temporary profit is going to see like, hey, is there temporary profit greater than 0? Yeah, in my case in here, 1 and 5, there would be, right? So remember, what do we do here? Check if my current price is less than my old price, right? So I gotta check what's my old price. My old price in here is 7, right? So I need to replace it. So I need to check if my current prices at I is less than my price of my original price, my buy price, right? If it is, well, let's swap it. So buy price will equal to price at I, right? So now what do we need to do? We've replaced it. Now we have to track our profit, right? So how do we track our profit? Compute profit. Our computer profit is greater than our old profit. So let's check if our computer profit, which is prices at I plus 1, right, minus our buy price, right, is that going to be greater than our current profit? And if it is, we will just replace profit with this beautiful thing. Cool. All right, clean up our code a little bit. And let's see if we actually solve this problem. Let me just delete all this pseudocode. Delete that. Okay, let's see. Like I said before, before we even run, because when you go through interviews, you're not always going to have a chance to go and compute or run your code. So I always like to just run through a quick example to see if this would actually solve the actual problem. So let's take a look at this example again. So when we set the buy price here, it's going to be originally at 7, right? So that's going to be $7. And our profit set at 0, and then we go through this array, right? So what do we do here? We're setting our temp profit. What's our temp profit in this case? First one. Well, our temp profit here is -$6, right? Is that greater than 0? No. So we skip to the next element here. And here we're going to go temp profit. What's our temp profit here? Our temp profit is $4. Is $4 more than that? Yes, it does. So let's check our prices at the current position. That is 1. Is that less than our buy price? Yes, it is. So let's replace it, right? So this will be 1 from here. And then we check the next portion here. So prices at that over here will be 5, right? 5 minus our buy price, which is 1, right? Is that greater than our profit? Our current profit is at 0. If it is, then great. Let's put our profit in here. Current profit here is $4. Let's move to the next pair. So once with that, clear this out. So next pair, 5, 3, is there a profit? No? Good. Next one, 3, 6, is there a profit? Yes, there is. So this profit is currently at $3, right? We check that's greater than 0, great. Now we check whether or not our $3 is greater or less than our buy price, which in our case, it is not. So we don't do anything in this one. And we compute the computed buy price, which is taking your $6 minus the $1, your original computer buy price. And is that more than our profit, right? So that, in this case, it's $5. So it will return $5. And we continue to go on and we solve the problem. Cool. So it seems like this will solve at least this particular example. So let's see if we can analyze the time complexity and space complexity. So the space complexity in here is really, we're just creating this one thing here, right? So it's still constant. None of our variables are actually growing. And we're only iterating through the array once. So we can actually make this super efficient like this. So let's run the code and see if we can solve this particular problem. Submit. Oh, runtime error. That's not cool. Why do I have a runtime error? Let's take a look. Oh, ha, silly me. There's a period here. All right, cool. So instead of period, it should be semicolon, and let's submit this question again. Great, we solved this problem. All right, cool. I hope this is a nice informative solution. It just shows you how we can solve problems really systematically. And stay tuned for the following episodes. See you guys. Thank you.